Hey, it's W5HRO for a quick update here. This will be part A. I did build up this little keep-alive supply with that old Peter Dahl desk kilowatt screen transformer. And I've got it all mounted there. I've got the red wire coming off of it that I'm going to run up here beside this. It's going to go to the pass transistors, then down to the solid state relay. I'm just going to go ahead and put the relay in there and use it, because what I realized is I have 12 volts coming off this. You can see I got all the wires pulled off. I'm getting ready to pull these racks out so I can work on them on the bench again once I get this other thing all done. I'll probably do it before I even do that, because what I'm going to do is the 12 volts that turns this relay on here for transmit, I'm going to use that same 12 volts to turn on that solid state relay. So when I transmit, this clicks on, it'll also turn that relay on. That'll make it easier. And I think what I might do is I might put that relay between the pass transistors and the limiter. So I haven't decided yet, but I've already got this ready. See, and something I realized is these heat sinks have an extra hole in the middle, and I looked at the other two out in the garage and they're all the same. There must have been a place to run wires on these for the original application these things were designed for. But it dawned on me, I can drill that hole a little bit bigger and I can mount that 10-watt stud mounted Zener right there. I could just put all three components on this same heat sinks, and I think if I do it right, the edge of the nut will hit the side of this thing, so I can tighten it down from the top, and that may work pretty good. So I think I'm going to put the Zener there. I decided I'm just going to go ahead and Zener this thing to start with. I'm just going to put a 200 volt stud mounted Zener on this, and use a dropping resistor and see what happens, and just set the resistance. And I'm assuming that the 200 volts will probably be just about right on this, because what you do is when you set the keep alive supply voltage on your limiter, you take your plate voltage times 10%, and my loaded down plate voltage is 2125. So 10% of that's what, like 210 volts, 211 something. That's basically what it is. So if a 210 volt Zener would probably be the ideal thing to use on this, but I thought, well, this thing has the modulator has so much power for this single tube up here that I thought, it may hit it may flat top. My positive peak may hit the positive rail. So even the 200 volts may be a little too much. And if it is, I'll order another Zener and I'll just change it and I'll keep dropping it down until I get it in the right spot. But I'm assuming 200 volts is probably going to be just about right. It may be perfect. So I'm just going to do that and just see what happens. So anyway, I did find the old data sheet on that, the spec sheet on that transformer I put in there, that old screen transformer. See, Johnson Desk KW screen. And there's the low voltage tap. So I'm on the low voltage tap to get the 530 out. Now, it's not 530 from end to end. It's from each, it's actually 1,000 some odd volt transformer from end to end from pin 4 to 6, but the center tap grounded, it's going to be the 675 or the 530, and I'm on the 530 volt tap at 130 mils, so that'll be okay. And I'm doing the same thing like I did for the 6,000 tube regulation. I'm using the transistors in series, one driving the other one for the current amplifier, so that'll help even more. So what I'm going to do is I'm going to mount this thing. Probably I'm going to mount the relay right here, and then the pass transistor block above it, or I'm going to do the reverse, but I'll just mount the heat sinks right here against the thing. But they're going to go right there, so that wire from that supply will come up. It'll go either to the relay and then get turned on and off through the input to the pass transistors, which is what I might do. I'm not sure I want to leave them on all the time and keep them hot. It'd probably be better just to have them on when I transmit. So that's why I want to use that 12 volt supply in here to turn it off and on. And that is a 12 volt relay, right? Let me look at it again. It's been so many years. Yeah, it's a 12 volt. See the dash 12, that's what it is. Yeah, 12 volt. Yeah, 12 volt input, DC input. So that'll be perfect. So I'll just use that regulated 12 volts coming off that relay supply for this to control that. So when that thing clicks on, it turns this thing on at the same time. So that'll be the solution. And I also got this 4 pole, but just a, you know, single position switch. It's like, or 2 positions, like on or off. You go click, click. There's just 2 positions on it. And basically all 4 of the poles, each side's all basically, like, you can wire them all up in parallel. What I'm gonna do is I'm gonna wire 2 of them up in parallel to use 2 of the switch contacts inside to get, you know, so it'll handle the current a little bit better. But the problem was, when I made the modification of this thing years ago and I put those regular tubes behind all this, I didn't have a lot of room for front to back on the inside of the chassis, so I had to use that small switch, that thin switch from front to back. But the only one I could find at the time had a short shaft on it, so it worked fine for the original knob, but these other knobs require a longer shaft, so I have to change it. And that's why I found these, because see how the depth is from front to back? That's not very thick, right? I don't even think I'll have to bend the terminals, because I have space in there between the end of the terminals and the tubes in there. So that should be okay. But I needed something from this dimension here between my thumb and my finger was small. And these are flat enough that I think it's okay. So I'm going to change that out and put that there, so I can put this same matching knob on it. So that's where I am on this. I've got my NTE transistors here, and I've got all the stuff I need. The only thing I don't, you know, I've got dropping resistors I can try. I do have one big Sprague Coulomb. I'm going to try it first so I don't have to mount anything. But I've got another little smaller black flat heatsink that doesn't have any fins that I can mount some dropping resistors on in parallel and mount it beside all this up in there if I have to. But I'm not going to need any more wood. I can just do it all on metal now, metal to the cabinet. I'm wondering, should I put insulators on this too? It may not hurt, because I wonder if that could ever internally short to the ground, the metal on the bottom of this thing. It might. I'm wondering, I may have to put some short insulators on this, but I'll probably just mount it on there first. Then I can always add the insulators if I decide to do it after. But this one for sure, because like I said, if the collectors short through the insulator to the heat sink, then the heat sink's going to be live, and I don't want it shorting out directly to ground and blowing stuff up on it. So I want it to still work for protection of the transistors and everything. So that's where I am, and I did get my antenna wire in, and we actually are getting a break in the weather, so I'm going to take my antenna. My antenna's all upstairs up here underneath the ceiling of the room above us, the main living room above us, and I've had it in the front room. I'm sure the XYL is going to be glad I'm getting all that junk out of the front room floor, because I've got the big telescopic mast in there all collapsed, the wires connected to it. I did the silicon RTV on all the connections up there on a big piece of cardboard. I had to let it dry overnight, so that's all done. So I'm hoping I'm going to get my antenna up by here, if not later today, tomorrow, the next day. The rain's coming back, but it's going to be kind of sporadic. Today we got a sunny day, so maybe I'll get lucky. So that's it for now. This is W5HR and an O.